Let's talk about how to check that ventilation and filtration systems are working properly. Now that we've learned how ventilation and filtration systems are designed to work, let's discuss how you can evaluate individual systems in your facility to determine if they are working correctly. We will describe inspections that you can do to identify concerns with your existing systems and the types of adjustments and repairs that can be done by certified technicians. At the end of this video, we will discuss what to consider when hiring a contractor. Effective July 1, 2014, California mandated that all new HVAC systems in commercial buildings undergo mechanical acceptance testing to verify the proper functioning of the system upon installation. Effective October 1, 2021, California introduced an additional requirement that only certified acceptance test technicians, or ATTs, can conduct this assessment. It's critical to ensure that this testing is performed when installing new HVAC systems and to maintain these records. With regard to indoor air quality, mechanical acceptance testing includes testing and documentation of the minimum outdoor air rate, economizer operation, demand control ventilation system operation, and the supply fan controls. Unfortunately, this testing is often overlooked. An important first step in assessing your HVAC system's health is to confirm whether acceptance testing was conducted during the installation. If this testing was neglected, there's a higher likelihood that your system may currently experience issues stemming from its original installation. There are some basic inspections that maintenance staff can do to evaluate the filtration and ventilation system. First, you'll want to make sure supply fans and exhaust fans are running at least 1 hour before scheduled occupancy and during all occupied hours, including when janitorial staff are working, to make sure ventilation and filtration are continuously being delivered to the space. The fan should be running all the time regardless of the heating or cooling status. Program the fan schedule in your thermostat or building automation system and make sure the occupants cannot turn off the fan. Some thermostats designed for homes do not allow programming a ventilation fan schedule. These types of thermostats should be replaced. A simple way to make sure your supply and exhaust fans are operating continuously is to attach a tissue to a pole and hold it up to the air vents. Supply air vents will blow the tissue around, giving you a visible indicator of air movement. Return or exhaust air vents will suction the tissue to the vent. Document any supply air or return air vents that appear to lack air movement in an inspection report for follow-up by a licensed technician. A licensed technician can configure control systems correctly and fix any problems with airflow distribution. Next, you'll want to inspect all of your outdoor air intakes. While this should be done periodically, it's important to do an extra inspection if there's a concern they were closed during a wildfire event. As previously discussed, a common ventilation system type is the fixed outdoor air system. These intakes, positioned on the suction side of the fan, serve to draw in fresh outdoor air. In the image on the left, we see a fixed outdoor air intake with an adjustable opening set with a pin, highlighted in red. Currently, the intake is fully closed, meaning there is no outdoor air entering the system. Fixing this requires configuring the outdoor air assembly to achieve the desired outdoor airflow. Conversely, the system depicted on the right lacks its outdoor air intake assembly entirely, leading to the unintended consequence of drawing in nearly 100% outside air continuously. Fixing this requires installing and configuring the outdoor air assembly to achieve the desired outdoor airflow. Document any fixed position outdoor air intakes that appear to be set incorrectly, missing, or allow no outdoor air at all. A licensed technician can measure outdoor air rates, adjust and repair systems, and modify existing systems to add outdoor air. Another very common type of ventilation system is an economizer. As we learned in an earlier module, this is an actuated damper assembly that can increase outdoor air for cooling the building when conditions permit. Most of the time, the dampers are stable at the minimum outdoor air position. When the thermostat calls for cooling and the temperature outside is below a set point, the damper should open up to 100% outdoor air. You'll want to inspect your economizer assemblies and make sure the system is working. This must be done when it's cool outside, below about 70 degrees Fahrenheit. First, set the thermostat set point to match the current temperature indoors so that the thermostat is not calling for cooling. Next, inspect your economizer and check if the dampers are partway open to the outside at a fixed position. Finally, change the temperature on the thermostat to trigger the cooling. The economizer damper assembly should move and increase the outdoor air and decrease the return air. If the damper does not move, then the economizer is not working. Another error that could occur is that the damper assembly might close instead of open the outdoor air damper. This happens when the control signal gets wired backwards or programmed incorrectly in the control system. Document any economizers that are not functioning or functioning incorrectly. A licensed technician can test, adjust, and repair economizers and ensure the controls are communicating correctly with the mechanical system. Next, you'll want to inspect your filtration system. Ensure that the filters are installed facing the correct direction. There are arrows printed on the filters that should align with the direction of the airflow. To check the airflow direction, note that the airflow should pass through the filter before the copper coil. Additionally, ensure that the filter sizes are correct and that they are installed correctly in the filter racks so that no visible gaps are present. Any air that goes through gaps does not get filtered. This is called filter bypass. As discussed in Module 7 of the series, you'll want to use 2-inch deep filters with MERV 13 filtration wherever possible and change them every 3 to 6 months. If you are unsure if your system is compatible with MERV 13 filtration, a licensed technician can measure the total airflow through the system and the pressure difference across the system fan to determine filter compatibility. In some cases, a technician may be able to make adjustments to the system in order to increase the fan speed and enable use of filters with a higher rating. Finally, while you are inspecting your HVAC systems, it's a good idea to check a few other items. When indoor air flows over cooling coils, water from the air condenses. This condensed water is pumped or drained outside by gravity. A common maintenance issue is blocked condensate drains or failed condensate pumps. Carefully investigate any water damage in your building to determine if it came from the HVAC system. When inspecting the air filters, inspect the cooling coil to check for any standing water or mold, which indicates a drainage problem and can be a source of indoor air pollutants. HVAC systems transfer heat outdoors with an outside coil and fan. The air moving over the outdoor coil is not filtered and can carry debris. Check your outdoor coils periodically and clean and remove debris as needed. Finally, while inspecting your HVAC systems, ensure that the service valves for the refrigerant circuits are capped with brass gasketed caps. These valves are generally spring-activated Schrader valves and are often missing caps. You should be able to locate them near the system compressors. Capping these valves prevents refrigerant leaks, which is important for system efficiency and performance. Refrigerants are also potent greenhouse gases that should not be released to the atmosphere. In this module, we reviewed a number of important inspections you can make to maintain your HVAC systems and identify problems. Let's review these briefly. Ensure that mechanical acceptance testing is completed for new systems and save the reports for future reference. Confirm that HVAC system fans are running during occupied hours. Inspect outdoor air systems and test economizers to make sure dampers are moving as expected. Ensure filters are installed correctly without bypass. Inspect indoor coils for standing water and mold to detect drainage problems. Document your findings for each system in an organized way and seek assistance from a certified technician to address any deficiencies you find. Certified technicians will have specialized training and tools to fix ventilation and filtration problems that you identified and documented with your inspections. Certified technicians can measure and adjust outdoor air rates, adjust and repair economizers, and install new outdoor air intakes and economizers on existing systems. They can repair or replace fans and balance air distribution in buildings. Additionally, they can adjust systems to use the best compatible filtration so you're confident that you're providing the best indoor air quality possible with your existing equipment. When selecting a contractor, we recommend that you require that any test, adjust, and balancing or tab work be completed by a certified technician. There are 3 certification agencies, which are the Associated Air Balance Council, or AABC, the National Environmental Balancing Bureau, or NEB, and the Testing, Adjusting, and Balancing Bureau, or TAB. Any work completed by the technician should have a complete TAB report and a copy of the technician's certificate.